We are Additive Automations, and this is our use case for separation of additive layer support by automation by a two-way digital twin. The presented solution was developed during the first Trinity demonstration, with the goal of improving the agility of European SMEs in the manufacturing industry. Additive manufacturing currently requires significant manual post-processing, a step that is holding companies back from embracing digital manufacturing. We are presenting a use case for robotic post-processing of additive manufactured components. Additive Automations is a company located in Sheffield, a city in the north of England with a long history of manufacturing and innovation. What you see here is the status quo in additive manufacturing. A highly skilled production line technician is tasked with repetitive and delicate manual post-processing. He's exposed to dangerous metal dust and works under pressure to produce consistent parts quickly. Elsewhere, a chief engineer is faced with high manufacturing costs, unacceptable scrap rates, and a serious bottleneck in production. The benefits of additive manufacturing start to look less and less attractive. At Additive Automations, we believe that the future of additive manufacturing must include intelligent automation of post-processing tasks. Production line technicians will teach and oversee a number of robotic microfactories, multiplying their productivity and eliminating the health hazards. Chief engineers will be free to take full advantage of digital manufacturing, with guaranteed consistency and a tenfold reduction in defects and operational costs. Eliminating this manual bottleneck will finally allow production to scale with demand. So why is this still a manual task in the 21st century? No two additive manufactured parts are exactly the same, and this inherent variability makes it very difficult to use rigid automation machines like conventional CNCs. Industrial robotic arms are more versatile, but programming them is currently difficult and slow. What you see here is how 95% of robot arms are programmed. It can take months to teach a single robotic cell. At Additive Automations, we're using proprietary computer vision and force control algorithms to compensate for variability and adapt robot trajectories. Our team is creating intuitive software tools that seamlessly merge teaching, simulation, and control of industrial robots. Our microfactories can be programmed in minutes to use any of our plug-and-play end-of-arm tools on additive manufactured components. We believe that this combination of intelligent software and adaptable hardware can help us achieve scalable, sustainable manufacturing. This Trinity use case presents an advanced user interface that handles planning, visualization, and control from one place, aimed at addressing the removal of AM support structures and other finishing operations for near-net shape parts. What follows is a video showing the different parts of our system.
Additive manufacturing enables the digital manufacture of high complexity parts in metals, composites, ceramics, and polymers. Finishing AM parts is still a largely manual process. Our mission is to complete AM's digital thread by automating these manual post-processing steps with a vision to eliminate the current barriers to entry for using AM in volume production. Additive Automations is a high-tech startup with a focus on creating positive changes for people and the environment. By addressing the hazardous, toxic, repetitive task of AM post-processing, we hope to improve the physical and mental well-being of people around the world. And by making additive manufacturing accessible to more industries, we hope to accelerate the adoption of sustainable, near-net shape manufacturing and bring about lasting benefits for our environment. We're using state-of-the-art sensors and processes to bring dexterity, versatility, and ease of operation to industrial robotic arms. A digital twin and a physics engine allows for fast, reliable planning, simulation and visualization of complex robotic tasks. the use of computer vision and a unique force control algorithm allows us to tackle delicate operations with confidence and with precision. The events of the last few years have highlighted the benefits of local and flexible manufacturing. Now more than ever, we hope that you will join us in our pursuit of a digital and sustainable future.
Our hope is that this use case may be useful for any industry struggling to automate a dexterous task requiring complex planning, machine perception, and closed-loop control, not necessarily only industries using additive manufacturing. For more information, please visit the Trinity catalog on trinityrobotics.eu. You can also get in touch via our website or by emailing info@additiveautomations.com. Thank you for watching.